So this video is going to be on converting the equations of conics by completing the square. So a lot of the time when we deal with these equations of conics, they don't come in a form that really gives us a lot of information about the conic. So we need to be able to convert them to the standard form that really does tell us what we need to know about the conic section. So this equation, we have x squared plus y squared minus 4x plus 2y minus 31 is x minus h squared plus y minus k squared is equal. I can do this by completing the square. Now notice that I'm actually complete the square twice to get it to this form, because I'm x minus something squared and y something squared and is equal to the cos side. So I'm going to start by dividing up my x and my y terms. So I'm going to write x squared minus 4x, and I'm going to put a plus blank in here because I don't know what that number is going to be yet, and then plus y squared plus 2y plus a blank, and that's all equal to 31. So I know that to complete the square, I take half of this middle term and then square it and then add it to the right where the blank is. So in this case, the middle term is going to be negative 4. I take half of that, and then I square it, and that's going to be equal to 4. So I know that a 4 goes here. But since I added a 4 to this side of the equation, I also have to add 4 over here. And I'll do the same thing here, so I have 2 over 2 squared, and that's equal to 1. So I'll put a 1 right there, and again I have to add this 1 to the other side. Now we can see that both of these, that is going to factor into a nice perfect square, as is this one. And it'll factor to x minus 2 squared plus y plus 1 squared is equal to 36. And now I can easily see that this is a circle, and its center is at 2, negative 1, and it has a radius of square root 36, which is 6. So we can see this form, I really couldn't get any information out of this form of the equation. But now that it's in this form, I can easily see where the center and the radius is and anything else I need to know about it, really. So moving on to example 2. Now here I'm going to do the same thing, except notice that I can't complete the square yet because I don't have a 1 in front of my squared terms. If this term right here is not equal to 1, then I cannot complete the square yet. So the first thing I'm going to do is I actually can see that every term in this is going to be divisible by 4. So if I can factor a 4 out of this whole equation, so I'm going to have 4 times x squared plus x plus y squared minus 8y, and that's still equal to 8 because I just moved this 8 to the other side. And now I can divide everything by 4, and then I'll have x squared plus x plus y squared minus 8y, and that's all equal to 2 now. And now it's in a form that I can actually complete the square since both of these coefficients are equal to 1. So I'll do the same thing I did last time. I know that this coefficient right here is an invisible one, so I take half of that, I square it, that's equal to 1/4. So I'll put in my 1/4 here, and I know I need to add 1/4 to this side as well. Same thing here, I take half of negative 8, I square it, and that's going to be equal to 16, and I add it to both sides. Now, this x squared plus x plus 1/4, we haven't really dealt with factoring when we didn't have all integers, but the nice trick about completing the square is not only is it always going to factor into a perfect square, but it's always going to factor into your x plus, and then whatever this term here was when you just divided it by 2. So this is going to be x plus 1/2 squared plus, and then this one we can see is going to be y minus 4 squared. And that's equal to 2 plus 1/4 plus 16, which is going to be 18 and 1/4. I don't really like mixed numbers very much, so I'm going to change that to 73 over 4. Same thing. 4 times 18 is 72, plus 1 is 73. So now, again, I can easily see that this is a circle with center -1/2, 4, and radius of square root, the whole thing, 73 over 4. And I know by my properties of radicals that that's actually square root of 73 over 2. So again, I didn't really have a lot of information from this top equation, but in the bottom I can clearly see everything I need to know about this circle. Moving on to example number 3. Now, this one's a little bit trickier because in example number 2 I had the same number in front of x squared and y squared, so it was easy to just divide both of those out. So here we have to do a little bit of a different kind of trick. So I'm going to start by grouping my x and my y terms together. 25x squared minus 150x plus 4y squared plus 24y equals -161. So I could try to divide both sides by 25 and then by 4, but that wouldn't work because then I'd end up with like a 1 over 25 here and a 25 over 4, and it would get really messy. So instead we have a different trick we're going to use for this. So I'm going to just look at my first group here, and I'm going to factor out a 25 from these first two terms. That's going to be 25 times x squared minus 6x. And that's going to be 4. I'll factor out a 4 from those second two, and that'll be y squared plus 6y. And that's still equal to -161. So now I can complete the square on the inside here, and I'll go ahead and do that. So I have -6 over 2 squared is going to be equal to 9. So I'll put a 9 in here. And then 6 over 2 squared is equal to 9. So I'll put a 9 in here. But what's different about doing it this way is that I didn't really just add 9 to this. Since this is in a parentheses that's all multiplied by 25, I really added 25 times 9. So when I add over to this side, I have to add 25 times 9, which is plus 225. And the same thing applies here. I'm not just adding 9, I'm adding 4 times 9. So that's going to be a plus 36 off over there. So now when I write this all out, I have 25 times, and now I can factor this to x minus 3 squared, 4 times y plus 3 squared, and this all adds up to 100. Now notice I still don't have it in standard form yet because this isn't equal to 1. So I'm going to divide every term by 100. And then I need to reduce these fractions here. Otherwise, it's not in standard form still because I can't have a coefficient in front of my x and my y up here. So 25 over 100 is going to reduce to 1 over 4. So that'll just be x minus 3 squared over 4. And 4 over 100 is going to reduce to 1 over 25. So that's y plus 3 squared all over 25. And now it's equal to 1. So it's in standard form. And I can see that I have an ellipse with a center at 3, negative 3. The center. And I can see that since 25 is my larger, then a squared equals 25, so a is 5, and b squared is 4, so b equals 2. And we can see this is actually a vertical ellipse, since the larger term is under y. One last example. And this one's going to work the same way. So I'm going to first group my x and y's together. 4x squared plus 8x plus 9y squared minus 72y equals negative 112. So now I notice I can factor a 4 out of here. So that's going to be 4 times x squared plus 2x and plus 9 times y squared minus 8y. And that's still equal to negative 112.